Good morning, Dr. Yuan and my fellow classmates. We're Group 4 of Detection Group, and our topic is Object Detection with Faster RCA and RescueNet. And our group member are listed here, and I'm Wang Zhao. Let me give a brief introduction about object detection. Just as the name shows, object detection is literally a method to detect instances of semantic objects of a certain class in digital images and videos. And the methods for object detection can generally be divided into two categories. The first one is about machine learning-based approaches. It's very traditional and useful. And the second one is deep learning-based approaches. It includes a lot of famous and widely used methods like RCNN and also SSD, as well as YOLO. So today, for us, we are using faster RCNN. I'm going to talk something about the development of faster RCNN. So the first question pops into our minds is, why do we need to introduce faster RCNN? And obviously that RCNN and fast RCNN are the two previous versions of faster RCNN. And the most important advantage of fast RCNN is that it can speed up the detection process rapidly. And we can see that it can shorten the process time by 250 times than RCNN. And how can fast RCNN achieve that? Let's have a look. Before 2014, the year RCNN was introduced, CNN was mostly widely used for the detection process. And as we all know that, for CNN, we just need to take an image as input and divide an image into various regions. And then all these regions would be fitted into the CNN and classified into various classes. And after we divide each region into its corresponding class, we can just combine all the regions to get the original image with the detected objects. And the drawback of CNN is also very obvious. That is, CNN also results in a huge amount of computational time. And the question comes, how can we reduce the number of regions in order to reduce the computational time? So we have RCNN, which is region-based convolutional neural network. And the advantage of RCNN is using the selective search to reduce the computation. So we extract the selected regions from an image ROI, which means region of internet. So there's also this green box we can see on the figure. ROI actually means that the region which has a higher possibility to have an object. And for the RCNN, there are three main models for us to do detection. After we have selected the regions of interest, we will have multiple convolutional network, CNN, to do the feature extraction. And also, after that, we can get the which class it will be. We can use linear or vector machine classifier for the identifying of objects. And afterwards, we can use regression model for tightening the bounding boxes. And also, the drawback is very obvious that because we are using multiple models, and especially for each regions of interest, we perform one time of CNN, we can see that the total number of the region can be up to 2,000. So actually, it still takes a lot of time to perform 2,000 times of CNN, as well as the SVM and the regression model. That's why we can introduce fast RCNN. Fast RCNN, we can just observe from these two figures. So it just swaps the sequence of the process passed to the CNN, which in turn generates the regions of interest. So for fast RCNN, it only needs to perform CNN for one time, and then generates ROIs, and then send them to the fully connected layers, and then we can do the further classification. So that's how fast RCNN saves time. Generally, fast RCNN uses a single model which extracts features from the region, divides them into different classes, and then return the boundary boxes for the identified classes simultaneously. Faster RCNN, it will not use selective method anymore, and a better method will be introduced by my group mates. So let me pass my time to my group mates.